These are the notes for Unit 3, Lesson 1 from Module K. The topic is the engineering design process. There are 3 learning targets for this lesson. The first is, I can explain how science, technology, and engineering are related. The second is, I can list the steps of the engineering design process in order. And the third learning target is, I know the difference between simple and complex technology. In class, I asked students to do 3 things. Define the 4 vocab words in their Google Notes. You can find those definitions on Think Central in the glossary. And then there are 2 Ed Puzzle videos to watch. They're both in Schoology as assignments. The first one is What is an Engineer? And the second is the engineering design process. In class, we talked about the 4 vocab words. Technology is the application of science for practical purposes. We'll talk today about how that technology can be either simple or complex. Technology doesn't have to be expensive or complicated. Engineering is the application of science and math to solve real-world problems. And the primary job of an engineer, as you saw in the Ed Puzzle video, is to solve problems. A trade-off is when you give up one thing in return for getting another. One example in the news recently is Volkswagen was just called out for modifying their cars so that they could pass emissions tests. So in the short term, they gave up meeting the standards to save some money. In the long term, they are giving up their reputation and a lot of money because they just got a big fine in exchange for a shortcut and saving some money in the short term. Then a prototype is a test model or your first version of a product. We read 2 pages in the student edition, so you can find these in Think Central. Open up the student edition and go to page 116. That's typed up at the top. We read about technology on page 116 and then how it can be either simple or complex on page 117. In that first video on Ed Puzzle, What is an Engineer? You saw some skills that engineers use, and there are a couple that are mentioned here that weren't in the video as well. Engineers research and gather data. They create models, like we learned about in the last unit. Engineers use math to solve problems. There's a lot of math in the field of engineering. They use computers to organize, apply, and store their data. In the last unit, we talked about making data tables and graphs, and that's something that you would expect an engineer to do a lot of. And then they need to be creative to come up with new solutions, like that trebuchet we read about on page 116. That was a creative solution to a problem of wanting to attack a city with high walls. Engineers work together, and when they come to an agreement, that agreement is called a consensus. So that's this word in parentheses. So engineers need to be able to work together as part of a team or a group to come up with an answer to the problem and then to build possible solutions, some prototypes, test them, and decide on the best solution to their problem. That's something you'll practice in the airplane lab tomorrow. In class, we're going to use a list of 8 steps for the engineering design process. In the video, you saw just 6. We're going to make these a little bit more detailed. So step 1 is to identify the problem. Step 2 is to do some research. Find out what's already been done. You don't want to waste a bunch of time if someone's already come up with a great solution to that problem. But also find out what people have tried that didn't work so you don't repeat their mistakes. Brainstorm solutions is step 3. Brainstorming means that you look at all of the possible solutions. In this brainstorming step, every idea is a good idea, and you write them all down because you never know. Something that doesn't seem like a good idea at the time might turn out to be your best option in the end. Step 4 is to choose a solution from your brainstorming list. Step 5 is to build a prototype. That's the first version of your product. Step 6 is to test and evaluate your prototype. Step 7 is a redesign to improve. So you need to figure out what worked with your prototype and what didn't work. Make some changes to make it even better. And even if you had a great working design, you never know. Something else you try might surprise you and be even better than the initial design you really liked. Maybe not. Maybe you'll end up using your prototype or something very similar to it. And then step 8 is to communicate your results. Then one of the learning targets is about comparing science, engineering, and technology and understanding how they all fit together. So this is a process map that I tried to put in your notes. It connects each of the terms with their definition. So you've got science, the study of the natural world, engineering, using science and math to solve problems, and technology, using science for practical purposes. Those are the 3 definitions of those vocab words from the book. And then the arrows here show the connections. So the field of science and the field of engineering share their knowledge and materials. When scientists discover a new material, like, say, the carbon graphite that's used now in things like bikes and golf clubs to make them lightweight, they share that information with engineers who then design a product using the information, like the actual bike or golf club. Engineers use science and math to solve problems, and they create that new technology. They build the new product that will meet a need or solve a problem. And then with new technology that's developed, like a new microscope, that information, those materials, and that tool are shared with scientists who can do new research. With a new microscope that can see even smaller things, then scientists can do more research to learn about very small things like cells or atoms. So it's a process. You can see how all of these fields are connected, and then notice that math is in the middle, because all of these fields use a lot of math, and that's a connection between all three fields. In class, when we read pages 116 and 117, we talked about the difference between simple and complex technology. So in your notes, we're going to add this T-chart, or you can just make two lists sharing the difference between simple and complex technology. So we learned in the reading that simple technology includes things that are simple to use and understand, items that are inexpensive. You can see all of the parts when you first look at them. They don't need to be plugged in. They don't require electricity. In contrast, I'll just fill this in quickly. In contrast, complex technology does require electricity. It's complicated. It has a lot of parts that work together. And it's more expensive than simple technology. And you can probably think of some other characteristics. Examples would be a computer for complex technology. And simple technology would be something like a book of matches or a zipper. Things that you didn't need to read an instruction manual to figure out. You didn't need to watch a video on YouTube. Where complex technology, I don't think I will ever understand all of the things that happen in my iPhone that allow it to work. It's like magic to me. So complex technology, those are things that you probably couldn't figure out on your own and that you spent a lot more money on. There are a lot of parts that you can't see when you just look at it. In class, tomorrow we'll be completing the paper and airplane lab, where you'll have the opportunity to work through all the steps of the engineering design process. So you've got that to look forward to. You'll work as part of a design team to create a great product, and we'll have a competition in class. I'll see you then.